So my name is Cormac Hogan. This is
not Frank Denneman. It's Duncan Epping.
Yeah.
Thanks.
So we kind of got together when the whole VMworld submission stuff came around, and we were trying to think of what should we submit. And so one of the things that we're heavily involved in is, in case you didn't know, is vSAN. And so we had a bit of a brainstorming session. We were thinking, well, what are the top things that people should know about vSAN? Customers, potential customers, partners, and so on. And so this is the kind of list that we came up with. So hopefully you'll get some useful pieces of information out of our session. Okay? Now, we do have to put up this disclaimer slide. We're not going to be really talking about anything future looking, at least that's not what we're planning to do, but you know, something might slip out by mistake, so just in case we're covered. So these are the things that we thought would be useful for you. How we're going to do it is we're going to kind of tag team. So Duncan will do one, I'll do another, and so on, back and forth. Yeah, no particular order to these, except that, you know, as I said, we had a sit down, we had a long think about what we thought would be useful to know for you folks, and this is what we came up with. So you're going to lead number 10?
Yes, I'm going to start off with the first one, but before I get started, how many of you are already using vSAN by show of hands? That's a pretty big number. First of all, thanks for being a vSAN customer. And second of all, hopefully some of the stuff in there is already familiar to you, at least this part. So this part is going to be for the people that didn't raise their hands. So when we talk about vSAN, we end up talking about object storage. So what is object storage? Well, some of you may be familiar with things like Amazon S3 or the Google Cloud Storage, for instance. And vSAN is kind of similar. It's object storage as well. And the big thing about this is that if you compare it to a file system, the big difference is that with an object type of storage, there's always a set of capabilities associated with the object. In this particular case, you'll see a VMDK, and it says RAID 1 configuration underneath. That's the capability that's associated with this particular object. As a result, in this particular case, this object is split into two components. Now, the great thing, of course, about this situation is that if one of the hosts goes down, the data is still available. So that's why we have this capability as part of the vSAN architecture. Now, there's also this witness thingy sitting underneath, and the witness that sits underneath is there mainly for availability purposes. You can imagine that when there's a partition between the two data nodes, we need to figure out who owns the data, and the one who owns the data is the one who still has access to this particular witness. Now, the question that then always comes, okay, you have this particular data layout. How do I control this particular data layout? Well, you do that through policy. And that's the big differentiator between vSAN and any other hyperconverged solution out there. All of the other hyperconverged solutions out there will give you an NFS data store, maybe iSCSI mounts or whatever it is. With vSAN, you have a single data store, just one data store. The layout of your data is determined by how you specified things like availability or performance within the policy itself. So as you can see within the policy, you have about maybe even 15 different options. But there's a couple that are really important. First of all, failures to tolerate, because failures to tolerate specifies how many copies of the data you have. This also indicates how many failures you can tolerate. The name already says it. So in this particular situation, you have 2 copies of the data. So you specified within policy, failures to tolerate is 1. If anything happens to a host, a disk, a flash device, or whatever it is, you still have your data available. Of course, the one thing that's missing here was that particular witness component. And the witness component is also stored on vSAN itself. Of course, it's going to be stored on a different host than the data itself. Now, the big thing here usually is, just imagine that there's a split between host 1 and host 2. That at some point in time, and hold on, so the virtual machine is running on host 4. We should have probably drawn the virtual machine as well, would have made it easier. Yeah. But virtual machine is on host 4. There's a split between host 1 and host 2, and both of them can still, or the virtual machine can still access both components. If there's a split between those two, then what will happen is that vSAN will actually drop one of those components, keep updating the component that is marked as live, And then if the split has been lifted, we'll resync the data to ensure that both of the copies are accurate and synchronized. Now, that witness thing is kind of a funny thing, because in the past we always would say, okay, if you have access to more than 50% of the components itself, so 2/3 in this particular case, then you have access to the data. But then we started doing things like striping, or we had 3 copies of the data, 4 copies of the data. We had things like RAID 5 and RAID 6, so it kind of complicated the design that we had. So what we introduced in vSAN then next was this concept of votes. So we started adding votes to each of the components, and now what we're actually looking at is at the number of the votes of the particular partition. And if you'd like to know what that looks like, you can actually go to the CLI itself, use Esxcli vSAN debug object list, and it shows you how many votes each of the objects have, or each of the components have. So doing that, you can figure out more or less how the architecture of vSAN itself works. There's one other thing when it comes to vSAN and policy settings that a lot of people tend to use, and I think it's probably something that's more used in EMEA than in the US, and the key reason for it being is that a lot of people end up striping disks for performance reasons. A lot of our customers in the US have already started moving towards all flash or are already running all flash, but the prices of flash in EMEA are significantly higher than they are in the US, unfortunately. So in this particular situation, you see a virtual machine and you see a lot of components, and in this case, it's, I think, 11 components across many different nodes. So the question always then comes is, okay, is this something that was specified through policy, or is this something that happened on the back end automatically? Well, that is something that you can find out actually looking closely at the screenshot. Now we'll get back to that into a second. Now if you look at striping itself, and I just said you could set a stripe width for performance reasons, there's also another reason why you could set a stripe width, or why striping may occur. So the other reason for striping to occur is when you have an extremely large virtual machine. From a vSAN perspective, we start striping a virtual machine across multiple devices, across multiple disk groups, or potentially multiple hosts, as soon as you hit 255 gigs. So when any virtual machine or a virtual disk grows above 255 gigs, we'll slice up that particular disk or particular VMDK and spread it across multiple disks. And that's how you can also recognize within the UI itself if something has been striped as the result of a policy or as the result of a large VMDK. In this particular case, you can see capacity disks on the right hand for you guys, and the green and the red boxes around it indicate that these are similar devices. So these slices have been stored on the same devices. That also means that this is the result of an extremely large VMDK itself. So it probably was a 2 terabyte VMDK sliced up in many different sections. If you would have specified a stripe width within policy, all of those disks or all of those UUIDs, those would have been unique. Reason for it being is, as soon as you specify it within policy, we assume you're specifying it as the result of performance requirements. So that's why we end up doing that. So now that you know a bit more about objects and components, Cormac is going to explain to you how vSAN works from a failure perspective, and what are some of the things you can do from a policy standpoint to get around certain scenarios.
Indeed. So Duncan mentioned a bunch of different configuration options that we can do in vSAN in that previous top 10 tip, let's say. He mentioned RAID 1, mentioned RAID 5, mentioned RAID 6. So these are all ways that you can protect your virtual machine. So I'm just going to delve into that in a little bit more detail first. So we have talked about the fact that you can have pretty much the default policy being RAID 1. And so that's your first copy of the data, your second copy of the data, and then of course that witness component, that small piece of metadata for quorum. But the whole point of this is that we can tolerate host failure, disk failure, and even network partition failure as well. So the thing with failures to tolerate, if you have it with RAID 1, the default policy is just to tolerate one failure, but you can increase that. You can tolerate up to 3 failures with RAID 1. The problem with that is the amount of space that it consumes on your vSAN data store, because if you're going to tolerate 3 failures with this RAID 1 configuration, you're going to end up with 4 copies of your VMDK. So that's quite an amount of overhead. So for that reason, we introduced erasure coding, or RAID 5 and RAID 6, in an earlier version of vSAN. So what that allows you to do is, again, tolerate failures. It doesn't matter whether it's host or SSD or network. But with a RAID 5 configuration, we consume so much less data, but we can still tolerate 1 failure. Again, with RAID 6, we can tolerate 2 failures, but again, we don't consume so much data. Now, our RAID 5 configuration is a 3+1, so it's 3 data segments and 1 parity segment. You need 4 hosts to implement that, because we need to put a segment on individual hosts. With RAID 6, we implement that as a 4+2, 4 data segments, 2 parity segments. So in that case, we need 6 hosts in order to tolerate those 2 failures. And by that I mean we could actually lose 2 of the 6 hosts in that configuration, and our VMs would still continue to function. Now, obviously, the host failures will impact the running VMs as well, so we have full interoperability with Vsphere HA to restart those VMs on the remaining hosts in the cluster. So we can do all that, but we can do some other cool stuff as well. So this is, I suppose, rack awareness is one way of describing it. If we did not have this rack awareness feature and we went to deploy a VM, it could be that all the components of that virtual machine end up into 1 rack. And so if that rack failed, even though we have 3 more racks, that's my virtual machine gone. Okay? So with fault domains, what we can do is we can set up a configuration that tells vSAN these hosts are in these racks. Okay, so let's say in this particular case here, I have an 8-node vSAN cluster that's spread across 4 different racks. I can tag these I can tag these Esxcli hosts as being in a particular rack. And now when I go to deploy my virtual machine, again, I'm just using the example of a RAID 1 configuration, vSAN is aware of which hosts are in which rack, and we're going to position the components belong to the virtual machine in the individual racks. And now at this point, I could have a complete rack failure, and my virtual machines would continue to run. Now, admittedly, once more, I might need HA to kick in to restart the VMs, but it's all good. Okay? So there's one other configuration that I want to talk about, and this is this particular one here. So this is, I'm not sure if the animation is quite right, but yeah. So this is, again, a similar kind of concept, but it's not just rack awareness within the same data center, but it's more of a campus cluster type solution. So what I can do in this particular case is I can say the Esxli hosts that are in room A or building A will go into this fault domain. The hosts that are in this room or this building, building B, would go into a separate fault domain, and so on. Now when I go to deploy my virtual machine, it knows once more through the fault domain concept where I need to place my components. Now the neat thing about this is it's like a campus cluster, but you don't need the stretched cluster configuration or enhancement that we have with vSAN as well. So this may not be for everybody. There is a requirement that the latency should be less, or the RTT should be less than 1 millisecond between the different rooms or the different sites. If it's above 1 millisecond, you definitely have to look at something like stretch cluster, which allows you to go up to 5 milliseconds between sites. But it might be something that could be useful for some of you who want to achieve a greater level of availability with vSAN across different rooms, across different buildings, maybe on the same campus. Okay, and again, you know, we can tolerate a failure of a building or a room, and our VMs continue to run. There is one final bit I want to talk about as well, and this is to do with stretch clusters. With our stretch cluster solution prior to the most recent release, we could only have 1 copy of the data at each site. So it essentially meant that if we lost a complete site, we were just running with one copy of the data, and a failure on the remaining side could impact the availability of virtual machines. What we've done with this 6.6 release is that we now have the ability to have local protection. So in other words, I could have a RAID 1 or a RAID 5 or a RAID 6 on each site, and those being replicated as well. So that basically means is I could lose a full site and I still have my virtual machines protected on my remaining site. And the one last thing about that is I can also deploy VMs that have a failures to tolerate setting of 0. And this might be for VMs that you don't really want to protect, you don't care about having them replicated. There might be inbuilt replication within an application that takes care of the replication, so I don't need the stretch cluster replication to do that. So we have that available as well. And VMs that are deployed with the FTT of 0, we can actually stipulate which affinity or which site they have affinity to as well. So you could have some VMs on site A, some VMs on site B. Okay. And it's all policy driven once again. So I do have this table. I don't expect you to learn all this off or anything like that. And in fact, the whole of this session is recorded as well. But this is just a nice breakdown of the number of hosts or what FTT I can tolerate using a particular FTM. It's just a fault tolerance method. Basically, it tells you whether it's RAID 1, RAID 5, RAID 6, and so on. But as I said, don't worry about learning this off. Pretty much all of this is going to be made available after VMworld anyway. So Duncan's going to talk to you now. I'm not sure what you're going to talk about, but that's the next. Do you know? That's good.
So we just spoke about a lot of the features that are policy driven, but there's also a bunch of features which are not policy driven. If you look at the UI itself, and if you enable vSAN, and I've said this about a dozen times now, if you enable vSAN, it's literally a couple of clicks. It used to be 2 clicks. Now for most customers it ends up being 10 or 15 clicks. Now, about a month ago, a guy phoned me up and he said, I'm trying to set up vSAN, and you said it was only 2 clicks. First of all, it took me 5 clicks. Second of all, it's not working. He forgot that there's, of course, some aspects as well from a networking perspective that need to be configured. So don't pin me down on the number of clicks. Now, we're going to talk about some of the capabilities that are part of the cluster creation workflow itself. As you can see, deduplication and compression are enabled from a clustering perspective, encryption as well, but also the stretch clustering functionality that Cormac just spoke about. Within the creation of the stretch cluster, for instance, you need to specify what the witness is. So that's all part of that cluster creation workflow. Now, first of all, deduplication and compression. Before I start going over this slide, are people already running all-flash vSAN by show of hands? Well, just a few compared to the number of people doing vSAN. So hopefully, when I ask the same question next year, the answer will be, or at least the number of hands will be slightly higher. If you look at deduplication and compression from a vSAN perspective, the way that we implemented it, it's slightly different than most of the other storage companies out there. vSAN itself has a disk group, and every single disk group has capacity devices and cache devices. As soon as you write to a caching device, what will happen from a vSAN standpoint when deduplication and compression is enabled is we will store that particular write in a normal fashion. So it's not deduplicated, it's not compressed in any shape or form. So the caching layer doesn't use deduplication or compression. As soon as the data moves from the caching tier down to the capacity tier, that's when we'll start doing the deduplication and compression process. Key reason for it being for us is that we want to acknowledge that write as soon as possible. As soon as we start doing the write or the deduplication and process in line, latency is added to the I/O path. So we'll acknowledge the write itself, then at some point in time we'll deduplicate and compress the block. Now when it comes to vSAN, what's good to know about vSAN deduplication is that it happens on a 4K granular level. We don't scan just part of the VMDK, we scan the whole VMDK. So any block you will write down to vSAN itself will potentially be deduplicated. Then next, when it needs to be stored, when it's a unique block, we'll also compress the block and store it somewhere in the capacity tier. If, for whatever reason, it's data that can't be compressed well, so let's assume the 4K block ends up being 3K, we won't write it down as a compressed block. We'll write it down as a regular block. Key reason for it being is that decompressing the data is probably going to be more expensive than the capacity savings at that point in time. So it's fairly smart when it comes to that. So big differentiator between us and majority of systems out there, our deduplication mechanism is a nearline mechanism, as we like to refer to it. Now on top of that, we also have encryption. Now hopefully most of you have seen the Vsphere Encryption announcement with Vsphere 6.5 last year. So a lot of you will probably wonder, why on earth did you guys create vSAN encryption? Because we already have an encryption mechanism that's part of Vsphere. Well, there's a big difference between the two. When it comes to Vsphere encryption, as soon as a virtual machine writes, before the data actually travels over the network, it is encrypted. So it reaches the vSAN data store itself or the caching device encrypted. That also means that when we want to deduplicate and compress the blocks, that every single block appears to be random data. So deduplication result is typically 0. So that's why we started looking at implementing encryption at a different level. So that's what we ended up doing. We took all of the modules that the Vsphere encryption team created, and we implemented them on the vSAN layer. So the big difference here is the following. When from a vSAN perspective you write down to disk, when you write down to the vSAN data store, the write will be absorbed on the caching layer, but will encrypt the data as soon as it hits the caching layer itself. So it's encrypted on the caching layer. Then when the data needs to be moved from the caching layer to the capacity tier, we'll decrypt the data, potentially dedupe it. If we can dedupe it, then we don't need to compress it. But if it's a unique block, we'll compress the data, then encrypt the data, and then store it encrypted as well. So again, the big difference between these two is that for Vsphere encryption, the data actually travels encrypted over the network. For vSAN encryption, the data is encrypted at rest. So as soon as it hits the vSAN data store, both in the caching layer and in the capacity layer. There was one other thing that I wanted to briefly mention, and those are the thin swap files. We have a whole bunch of customers that have pretty large environments, and some of them are doing all flash. And in some cases, they have substantial amounts of memory assigned to those virtual machines. Now with vSAN, when you create a virtual machine and you have, let's say, 8 gigs worth of memory, it's going to create a swap file. It's not going to create one swap object, or it will be one swap object, but there will be 2 components as a result of that. And those components will be fully reserved, which is kind of similar to eager 0 thick, which you have with a regular swap file as well, which means that that 8 gigs now is 16 gigs at the back end. What a lot of customers were telling us, they said, well, that's great, but I don't overcommit from a memory perspective. So is it possible to create thin swap files? And that's something that we introduced in vSAN 6.2. So within vSAN 6.2, you can use an advanced setting, which is swap thick provision disabled. If you set that setting, all of the swap files that are created after you've set the setting will now be created in a thin manner, so unreserved. That also means that you don't need additional disk capacity for those swap files. Now do mind that if you end up running out of disk space, this is typically the screen you end up seeing, right? The virtual machine freezes. So make sure that when you enable these thin swap files that you have plenty of disk space available. And with that, I'm going to hand it over to Cormac, and he's going to talk about the impact of some of the policy changes.
So I guess one of the major things you want to avoid on vSAN is having rebuild or resync traffic. Now that's unavoidable in the event of a failure, because vSAN will self-heal itself and will rebuild missing components and resynchronize. But you can also introduce this resync rebuild traffic if you're not careful, and it can be done with something as simple as a policy change. So we do talk about the ability to change policies on the fly, and it is something that, if you want to go from a RAID 1 configuration to a RAID 5 configuration, or increase the number of failures to tolerate, you can actually do that with a very simple policy change. But the kind of advice that we're giving you here today is to treat those policy changes as a maintenance task. And the reason will become clear now in just a moment. So changing something like the FTT, so what we do in that particular case is that we'll just instantiate another copy of the data on another available host somewhere in the cluster, and then we'll just resynchronize up to that. It's not a complete object change of the VMDK or the objects that make up the virtual machine. It's more of like an appendage onto what already exists for that VM. However, you still will have resync traffic going on as we synchronize up the new copy of the data to the existing copies. So that one isn't quite so bad, but there's some other ones. So for instance, if I want to change the stripe width, now Duncan talked a bit about stripe width already, the fact that we would sometimes consider changing or increasing the stripe width in the case of performance. So you might already have VMs that are deployed with a stripe width of 2, and the data is striped across those 2 components and then replicated in the mirror. Now let's say that we've decided that a stripe width of 4 is more suitable for this set of VMs. So you can go ahead and build a new policy or edit the policy that already exists. And at that point, vSAN will tell you, you already have a number of VMs that are running this policy. Would you like to reapply these changes now or do it later? If you apply it now, what we do is we instantiate brand new VMDKs with the new stripe width. We synchronize the old VMDK with the stripe width of 2 to the new one with the stripe width of 4, and then when the synchronization is complete, we throw away the older components. So that's, that if you're going to do that to a bunch of your virtual machines, you can consider that there's going to be a certain amount of overhead incurred with all of this resync and rebuild traffic. So again, the kind of the advice we will give you is to treat these policy changes, which are very simple to do, but have quite an impact on vSAN, treat them as maintenance tasks. Okay, so there's a couple of other ones actually. Changing RAID protection, mentioned that going from RAID 1 to RAID 5 to RAID 6. Again, we instantiate new copies of the objects. So if we leave the RAID 1 in place, and let's say we're going to a RAID 6, what we'll do is we'll build a new RAID 6, and then we'll synchronize everything over to the new components or objects of that particular VMDK. And then when that's complete, we discard the original. The other concern with doing something like that is because you're instantiating a brand new object. I mean, we're not appending now. In this case, we're creating a brand new VMDK in most cases. You're going to need twice the amount of data so that we can synchronize the data that's already there to the new data or the new object. So you're going to have the old object and the new object in place at the same time while that synchronization is taking place. And then, of course, you'll get your capacity back when we discard the original object. But for a particular point in time, you're going to have duplicate or twice as much data being consumed. So just bear that in mind as well. So there's not just the rebuild, resync traffic that you incur, but there's also the capacity requirements that will be needed in order to make this change. So there's a few other ones as well. Some of them may not be quite so obvious. I know a lot of you seem to be still using the hybrid configuration, so some of these will be quite applicable. Increasing, decreasing number of failures to tolerate, like I said, it's just appending in most cases. But the thing with hybrid configurations is there's a policy setting called read cache reservation or cache read cache reservation. So this is the ability to take some of the read cache and associate it directly with a VM. If that's in place, then it's creating the new object, synchronizing the old object to the new object, and then throwing away the original. Enabling, disabling checksum has no effect. That's quite fine. We talked about the increasing and decreasing stripe width and the RAID protection. Object space reservation is a bit of a strange way. You wouldn't think that as well. But object space reservation on vSAN is basically a way of creating thick VMDKs. Everything that we provision on vSAN by default is thin, but object space reservation allows us to specify a certain amount of thickness. If we decide that we have a policy that we want, or we have a VM that we want to increase the thickness of, we instantiate the new policy or the new components, new objects. We synchronize against the new object, and then we discard the old one. So it's something that you might not think has a major impact on the traffic and the capacity at the back end, but it does. And then the final one here as well, read cache reservation. If you increase the read cache reservation, we get the same sort of scenario where we instantiate the new object with the read cache reservation, and then we synchronize once more, When the synchronize is complete, we discard the old one. So I guess I keep reiterating this, but treat these policy changes on the fly as maintenance type tasks. Don't do it during production hours if you can help it. And certainly don't do it to hundreds of VMs at the same time, because obviously the effects speak for themselves. Cool. So Duncan's now going to talk to you about some health check stuff that you may not know about. Cool.
Yeah, I was just in a meeting with a bunch of customers and partners, and the one thing that stood out to me is that we had 6 vSAN customers in the room, and only 3 actually looked at the health check itself. So that's the first thing I want to emphasize is if anything is failing from a health check perspective, look at the tests that are failing and try to solve those tests as soon as possible. I mean, there's a reason we have these things because it indicates what's happening to your vSAN cluster. There may be a disk dying. Could be something wrong with a disk group. A caching device is not well. The latency from a networking perspective, if you have a stretched cluster, is exceeding the limit that we have, that is 5 milliseconds. Or there's something happening, to the data itself, or components are missing. You're not following the hardware compatibility list. There's all these different things that could go wrong in your environment. And typically when something is wrong in your environment, this is where you will need to start. Now, what a lot of people don't seem to know is that if you look at the health check, you have this long list of all of the different things that just went wrong in your environment. In this particular case, we have 4 tests failing and 1 warning itself, that if you solve the top test, you probably will solve the rest as well, because all of these tests have been weighted. So in this particular case, what we did is we introduced a partition between 2 stretch locations. So what happened in this particular case is that you see 4 tests failing, but if you would solve the top one, which is the networking part, the partition itself, then you would solve all of the other 4 instantly. So always look at the top test first, solve that one, and then if there's anything remaining, look at the next one. The other thing that some customers complained about, and that's the question I asked the customers that I had the session with earlier, is why you're not looking at these health check? And the main reason for them was they had 1 or 2 tests constantly failing. In their particular case, in this particular case, they had a witness stored somewhere and they had an MTU setting of 1492 and we test for an MTU setting of 1500. So that test would always fail. If that's the case, you can actually use RVC, which is one of our CLIs, and I think Cormac is going to talk about that a bit more, but you can use RVC to disable specific tests. You can run this command in interactive mode, select the test that you want to disable, and just go back to the health check itself, click retest, and that particular failed test will now disappear from the list. Very, very useful. Of course, preferably you should solve the problem first, but if you can't solve the issue itself, then disable that particular test, because otherwise you'll end up not looking at the screen anymore when it always has that X in there. The other thing that we recently introduced is configuration assist. Now, I don't know if anyone looked at the latest vSAN releases, but vSAN configuration assist allows you to do a couple of things. For instance, it allows you to install or configure DRS, for instance. Is there anyone in the room that doesn't know how to configure DRS or HA? Yeah, I wouldn't raise my hands either. But that is something that this particular option allows you to do. But it's not the best part of this feature. This is the best part of the feature. It's upgrading or updating firmware. I'll ask a similar question again. Does anyone enjoy updating firmware? Again, no one. Yeah, him. Of course. There's always one guy that likes it. You probably work for a vendor, I'm guessing. But anyway, this new feature allows you to update firmware in a couple of clicks. Basically, we have the option to download the firmware itself, download the packages that are required to update the firmware. So some of the CLI tools that you need, you simply click update and we can go about updating Dell, Lenovo, Fujitsu and Supermicro at this point. There's others coming in the near future, by the way, so this is going to be opened up for other partners. The other thing that we recently introduced, and this was part of vSAN 6.6.1, is the cloud-connected performance diagnostics. So we have a lot of customers that like to test out what vSAN is capable of doing, and then when they get the results, they see 50,000 IOPS, maybe 80,000 IOPS, 4 milliseconds latency, and they wonder, what does it mean? Well, they are just numbers, right? So it's very difficult to assess what those numbers mean, and also what you can do to improve those numbers, and do those numbers actually match with the goals that you had. If you're aiming to drive a high number of IOPS, for instance, is it a high number of IOPS? Relative to the kit that you end up buying, right? So we have this cloud-connected performance diagnostic solution that allows you, when you run a particular benchmark, to actually select the benchmark in the UI. When you run the proactive test or HCI bench, you can select the benchmark, and then you can select the goal that you had for this particular benchmark. So let's say a high number of IOPS, and then what will happen is we'll feed the data up to our cloud, we will analyze the data itself, and then provide you with some hints and tips around how you can improve either the benchmark to achieve your goal, or how you can improve your environment, because in some cases you may not have sufficient disk groups or sufficient hosts or whatever it ends up being. There's a whole bunch of these different recommendations that we have to ensure that you're capable of hitting the goals that you have from a benchmark perspective. From my perspective, probably one of the coolest features that is part of vSAN right now, especially for the people doing a lot of POC. So any of the consultants will find this really, really useful. There's one other cloud-connected feature that we have, and that's the cloud-connected health check. I don't know if anyone has looked at the cloud-connected health check yet, but it's very similar to the health check. The big difference, though, is that from a cloud-connected health check, what we do is we end up looking at our KB articles and match the KB articles with your particular environment. So if you're running a Dell H730 disk controller, for instance, and there's a specific setting that needs to be set, and that has been explained in the KB article, we'll inform you about the KB article, we'll provide you a link, you can click through and actually apply those settings.
Right. I'd say we're only just getting started here. You know, some of the thoughts about what we could do going forward with this stuff, I think it'd be very cool.
Correct. Now that we've seen the health check, Cormac is going to talk about troubleshooting,
Indeed.
Which is the most exciting part.
There you go. Yeah, so just really, so I'm sure some of you are aware of many of the tools we have available to us. This is really just to delve into in a bit more detail. But there's one thing we do want to make perfectly clear, okay? Invariably, and this is talking to our GSS guys, if there is a resource issue on vSAN, and so things are maybe slow, unresponsive, or whatever the case may be, host reboots are not going to help you. Invariably, they're going to make things worse. Okay? Because you're simply, all you're doing is you're taking resources that vSAN requires out of the picture, thus making whatever the situation is worse still. Okay? So avoid this at all costs. I mean, if you're stuck and you're not quite sure what the next step is, reach out to our GSS guys. Let them log in and let them have a look around and see if they can figure it out for you. So what tools do we have available? So Esxcli, so there is a vSAN namespace with Esxcli, and we continue to add to that. And I'll show you some of the cool new features that we have there. Invariably, Esxcli is where we see the CLI troubleshooting tools going forward. We also have the Ruby vSphere console. Now, Duncan mentioned this as well. And yes, we continue to add some new tweaks to that from time to time, but the long-term goal is for RVC to be deprecated, and all of the things that we can do in RVC, we're going to try and pull into Esxcli. Okay, so you can get global views from an individual host, rather than having to go onto your vCenter server and run RVC. Power CLI as well. Every release, we're seeing new and improved commandlets from the Power CLI team. So you'll be, if you're a scripter or whatever, pretty much you should be able to do any task going forward through the Power CLI, and even API calls or whatever the case may be. And that continues to be enhanced on every release as well. Now, the other two that I've listed here, the CMMDS tool and the vSAN health status, the Python script there, those are kind of doing the same thing. They're more GSS orientated tools, but CMMDS is actually giving you the overview of who's participating in the cluster, what are all the objects. It's basically a directory service. the monitoring and management directory service. It's basically all the different components that are within your vSAN. Now, CMMDS tool on its own is a little bit obscure because everything is returned as a UUID, and you kind of have to track down what that UUID refers to. Is it a disk? Is it an object? Is it a component? Or whatever. That's where the vSAN health status Python compiled Python script comes in. It's pretty much like the CMMDS tool, so you can query the configuration of your vSAN cluster, but it actually has a human readable output, so all the UUIDs are mapped to particular names like host or disk or whatever the case. So I would say that RVC is still probably the most powerful tool that we have in our toolbox for troubleshooting, but long term that's going to be deprecated, and you'll see more and more extensions coming into the ESXCLI vSAN namespace, and I'll show you a few of those now. So this is just the output of the namespace, all the different ones that are there. I think the newer ones here is the debug one for sure, but we're going to do a bunch more things about this going forward. So just to give you an idea, this is something prior to the 6.6 release we could only get with RVC or through the UI. So things like the limits, such as how many components are being consumed, what's the maximum and how many have we actually used, and then the free space on disk, and then down at the bottom here we have the read cache reservation information, which again is only applicable to hybrid, but you can see it here that it's been displayed for you as well. And there's another nice one. This is the ability to be able to look at the different controllers that are on the host. Is vSAN using this controller, or is vSAN not using its controller? What's the driver version? What's the driver name? QDEPs, all of that good stuff. So as I said, you'll see more and more stuff getting added here over time. So cool. So now that we talked a little bit about troubleshooting, I guess this is probably a common theme in that space, maybe something that might go wrong in your vSAN cluster, so I'll let Duncan take over again.
Yeah, unfortunately, every once in a while a host dies or a disk dies, and when that happens, vSAN knows two states. So the first state is degraded. In that particular case, it's very similar to a permanent device loss with a storage system. vSphere knows what has happened to that particular device. So as soon as we know what has happened to that particular device, it's in the PDL state. What we'll end up doing is that all of the components that were stored on that particular disk or disk group will immediately be rebuilt. So instantly, which means that within literally a split second, you will see new components starting to pop up, and you will see resync traffic happening within the environment itself. Now there's another situation where, for instance, a host could die. In that particular case, if a host disappears or someone is doing a reboot for troubleshooting purposes, apparently, it could be that that particular host, or at least the components that are stored on that particular host, end up showing as absent. In that particular case, it means that vSAN doesn't know what has happened to the components, or at least to the devices or to the host that those components were stored on. What we'll end up doing in this particular case is wait for 60 minutes before we start rebuilding. The key reason for doing this is that, unfortunately, we do have customers actually clicking reset or rebooting hosts without placing them in maintenance mode, and we don't want to start rebuilding 50 VMs, 100 VMs, 20 terabyte worth of data if there's no need to rebuild that particular object. So we'll wait for 60 minutes. As soon as the 60 minutes has passed, now the rebuild will start. And of course the question then always comes is, okay, I know that particular host has died. Can I also shorten that time frame? Because after 15 minutes, I like to make sure that my virtual machines are reprotected again, or at least we're aiming to reprotect them. And in the UI itself, there's actually a button. So if you go to the health check, it will show you an option which is called repair objects immediately. As soon as you hit that button, the timer doesn't matter anymore, and all of the objects will start resyncing. The other option you have is setting an advanced setting. If you know, for instance, that a reboot always takes 10 minutes or 15 minutes, and it's not going to take longer than 30 minutes before the host is fully powered up, then of course you could set vSAN clone repair delay and actually shorten the amount of time that it normally would take before the resync starts. Okay, so we spoke about deduplication and compression earlier. So what if a disk fails or a caching device fails in the case of having deduplication and compression enabled or having deduplication and compression disabled? Well, first of all, if you have deduplication and compression enabled, then if any of the capacity devices fails, that particular capacity device is dismounted and that's it. You can simply replace that capacity device and that's where it ends. If the caching device of a disk group, however, fails, the full disk group fails because there's nowhere to land the writes on, so keep that in mind. Now, the big difference between deduplication enabled and disabled is what happens when a capacity device fails. If you have deduplication enabled and a capacity device fails, now that whole disk group becomes unavailable. So keep that in mind when you have deduplication and compression enabled. The reason for this is metadata. If you look at the disk group itself, when we have deduplication and compression enabled, we'll end up striping the metadata across all of the capacity devices. So if one of the capacity devices will fail, of course the metadata is impacted, and as a result we'll unmount or dismount that particular disk group. Now, of course, I know someone is going to ask the question at the end of the session, do you know if something is failing? Actually, we know something is failing. In a majority of cases, when a device fails, what you'll end up seeing on the back end is that the performance of that particular device, and whether it's a flash device or a spinning disk, the performance of that particular device will start degrading. If that happens, then vSAN has an algorithm to actually detect that the performance of that particular device is degrading and will place it in a certain state. As soon as that device raises that particular state, we're also capable of actually moving the data out. And we'll, of course, will inform you through the health check. So at that point in time, when we know something is going to fail, we'll raise the health check alarm for the DDH, degraded device handling, as it's called. Maybe in the UI it's still called dying device handling. But either way, we'll raise the alarm and you know that you'll need to be replacing that particular disk. Okay, well, we've reached a particular state, maybe a disk is dying, then what? Well, you can use maintenance mode. If you want to reboot a server, even if it's for troubleshooting purposes, because we all know we still end up doing it, please place it in maintenance mode first. The key thing with maintenance mode is, as soon as you place a host or a disk or whatever it is in maintenance mode, we'll end up informing you if you need to move data out of that particular host. If for whatever reason a virtual machine is impacted in any shape or form by, for instance, another failure, we'll tell you that before you can place this host in maintenance mode, we'll need to move the data out. We'll even tell you how much data we'll be moving, not just for a host maintenance mode, but also, for instance, for a disk. Unless you have deduplication and compression enabled. If you want to place a disk in maintenance mode, you can't do that with deduplication and compression enabled. So if you're one of the partners out there, or you're an architect at your local company, think about those things when you start architecting vSAN, because there may be an implication when it comes to the operational aspect of things. And with that, Cormac is going to talk about some of the different networking topologies.
Yeah, so I suppose one of the major changes that we introduced in the 6.6 version of vSAN was that we finally got rid of multicast. So I have a note here, pause here for applause. So I know we've got that feedback, I think, from the very first release of vSAN is, why are you doing multicast? Okay, so we finally listened and we've got rid of it in 6.6. But there are some considerations around using Unicast over multicast that I just want to quickly run through with you here. Okay, so I guess I don't have to spend too much time on this really. I mean, we did have a hard requirement on multicast being required for your vSAN cluster. And so, you know, this involved doing a lot of complex stuff like getting the switch configured correctly. You might have to set up IGMP snooping. If you were routing your vSAN traffic, in particular if you had a stretched cluster and it was going over an L3, then you had to set up something that would route the multicast traffic as well, so you were dealing with the PIM protocol as well. So, you know, obviously lots of complexity. We have listened, so we've now moved to a unicast type configuration. So just very quickly, the fact that now we don't have multicast with this whole managing of a group of hosts that can all communicate to each other, we do need a central point of something that will take care of who's a member of this cluster, who's joining the cluster, who's leaving the cluster. vCenter server is now the point that, or the source of truth, let's say, for what hosts are in the vSAN cluster. So it tracks things like, the cluster UUID, the node UUID, and all of that stuff as well. Is the host a data node? Is it a witness host in the case of Robo or Stretch cluster as well? And the usual stuff there as well. So any kind of changes such as the cluster forming or nodes joining or leaving the cluster and so on, these all trigger an update to vCenter to say, okay, this is the latest state of who is in the cluster and these are the members. Also something like an IP address change of the VM kernel interface for your vSAN traffic would cause that as well. Okay, so this is where it becomes, I suppose there's some considerations at this particular point. Now, obviously, if you're coming from a 6.5 or a 6.2 release of vSAN and you're moving to 6.6, you're going to have a combination of multicast and unicast, effectively. So what we do is, until the last node in the cluster has been upgraded to 6.6, we will continue to run multicast. And then at the point where the last node has been updated to 6.6, we flip over to unicast. But what would happen then if I started adding additional nodes to the cluster? Well, if I'm running 6.6 and everything is running unicast, and then I introduce an old node to the cluster will revert back to multicast to allow it to join the cluster. If, however, I'm running 6.6 and I've done the on-disk format, so all of my cluster has been upgraded to 6.6, and then I do the on-disk format change. We have a version 5 on-disk format for 6.6 as well. So all my nodes are running 6.6, they're all running on-disk format, version 5, the latest, and then I try to add an old node to the cluster, it will not be allowed to join the vSAN cluster. So it can join the vSphere cluster, but it'll be partitioned from a vSAN cluster perspective. So just keep that in mind, okay? So as soon as everything is upgraded to 6.6, we flip to unicast. As soon as you upgrade the on-disk format to version 5, we'll never allow an older node to join that cluster again. Okay. So that was just, I think the unicast you're going to talk about. I suppose it's a little bit more of troubleshooting and monitoring in that respect, I guess.
Exactly.
Yeah.
So I've already spoken about the health check, and the question that typically comes is, okay, the health check is cool, but it kind of shows me what my environment is doing right now, right? It shows me what the state is of my current environment. Of course, we're storing some of the health check information in the event, so you can see some of the historic data, but that's more or less it. So what else can you use to start monitoring vSAN? There's a couple of different options. Of course, there's the web client, and in the future there's going to be the HTML5 client, so we're working on supporting that as we speak right now. But there's a couple of other things as well. There's the vCenter VOPS, and I'll explain what that is in a second. There's VROPS, there's Log Insight, and there's this cool monitoring tool which is mainly for performance, which is Esxcli. It's developed by a couple of guys from the community. They developed that in their spare times, as far as I know, and it's available for free. So look at Esxcli if you want to do performance monitoring, a really, really cool solution. First, let's have a look at these VOPs. What are these VOPs? Well, the VOPs are VM kernel observations. So these are events that are triggered by the VM kernel itself and are stored in a log. As soon as they are stored in a log, you can actually have an alarm triggered by that as well. Now, first of all, of course, you need to figure out what of all the different VOPs are. And there are quite a number. I think there literally are thousands. For HA, for instance, I think I've seen 50, 60 different ones. Things that are triggered when the VM is being restarted, when a NIC has failed, when something has happened to a data store, you name it. There are all of these different VM kernel observations that you could get triggered. Now, first of all, as I said, you need to figure out what they are, and there's a event file for that, so it's event.vmessage, and it shows you all of the different events that the VM kernel can identify. And as soon as one of those events has been identified, an entry will be logged in the VOP log, and based on that, vCenter can actually trigger an alarm. So if you go to those VOPs, you can look at the whole list and then figure out what's important for your environment. Has a disk failed? Is there a PDL scenario? Is there an absent state? Has anything happened to one of my components of a particular virtual machine? And as soon as that happened, vCenter can now raise an alarm as soon as you've created a custom alarm for that particular VOP. It's very straightforward to create this. It's only 2 screens, but the only thing you really need is that Verb identifier, which you can find in the vMessage file or in the log file itself. So make sure you use those. For the most common ones, for vSAN, we've already set these up. But for HA, for instance, or DRS, they haven't been set up. So there are others that you will need to look at from a networking perspective maybe, or maybe some of the other clustering aspects. Now, of course, we also did a lot of integration from a VROps perspective. And I think this dashboard is probably one of the coolest I've seen from a VROps perspective in a while, because it shows you for the whole environment, not just a single cluster, what's happening in one single overview. It shows you the latency, it shows you the IObserve, the number of virtual machines running on top of vSAN. VROps in this particular scenario can actually show you what the performance difference is between virtual machines running on top of vSAN and virtual machines running on top of the traditional storage. So a pretty compelling story if you ask me, and this solution more or less comes out of the box, so it's very useful to look at that. But more interesting, in my opinion, is Log Insight. I don't know, are people actually using Log Insight by show of hands? A significant number. In the US, the number was a lot lower, I must say. What surprises me is that not a lot of people are actually using any form of syslogging services. Guess what? If you phone up support, right, and you by accidentally rebooted your server for troubleshooting purposes, they will start asking for a lot of these log files and traces. But if you haven't used a syslogging service, it could be that the trace file or the log files have just disappeared because it was stored in non-persistent memory. So Log Insight could help you with that. And the cool thing about Log Insight, in my opinion, is that it shows you a lot of different things about the state of your environment, whether components are going stale, so they're not being used anymore, what the liveliness is of an object, so if it doesn't have network access, for instance, if that has been lost. But also, it has the ability to specify queries, manual or create your own queries, in particular for vSAN. So it has this interactive widget, and within the widget you can specify what you are looking for. It gives you a couple of examples, and you can start editing those examples. I think it's probably one of the coolest solutions that we have out there, which is probably underused at this point in time. Mm-hmm. And now last but not least, Cormac is going to talk about, well, it's not actually a feature, it's something that you don't want to see in your environment, right?
Well, you know, I suppose this is one of the misconceptions, because congestion is actually normal in vSAN. Congestion is a throttling mechanism, and it can happen for very many reasons. So in the interest of time, I know we're cutting it quite close.
Hey, you've got 6 seconds.
Yeah.
I'm just kidding.
Okay. So we're not going to go through the whole of the vSAN architecture, but there's a whole bunch of layering that takes place. But when we talk about congestion, we're talking about the log structured object manager, which is essentially the low-level disk piece of the architecture. So it's the LSOM bit, which is talking to the SSDs and to your spinning disks, your cache, your capacity devices. This is where congestion arises. So here we have the caching tier and the capacity tier. We have what's known as LLog. That's the logical log where we track what's going into the caching tier. We have the plog or physical log. That's where we track what's going into the capacity tier. And we need to do this because of the distributed nature of vSAN. We might need to replay or roll back and just verify that what we intended to write to disk actually got written to disk. So the LLog congestion occurs here, and this is particularly when you have a lot of VMs generating a lot of workload. So in essence, you're talking about running workloads that the underlying vSAN configuration is simply not capable of handling. So it could be the SSD is not, designed to take that workload, or it could be you're simply running too many VMs. Now the physical log layer, that's congestion arises here if there's difficulty in destaging what's in the cache to the capacity tier. So these are the two areas where you'll see that, and I'm pretty much out of time, but it's essentially to do with overloads in particular areas, and then we introduce throttling to address those overloads. So what could cause it? It could be, as I said, overloaded system. It could be network problems as well. So we're able to do pretty much a good amount of I/O to some hosts, but we simply can't get the same amount of I/O driven to other hosts in the cluster due to network problems. And so we have to introduce the throttling on the good hosts so that everything is balanced. hands up, we could have issues with vSAN software as well, and we've had issues in the past. And so the recommendation here is that you be running a vSAN version 6.0 patch 04 or 6.5 express patch 02 or higher than those versions if you're running a 6.0 or 6.5 version of vSAN. And then just a weird one, wrong configurations in the BIOS of the Esxli or on the host. And there's a KB article which talks about that obscure one as well. So there are a number of reasons why congestion arises, but it's not an issue to see it. Congestion spikes from time to time. That's perfectly normal. But obviously, if you have congestion for a long period of time, that warrants further investigation. So I do apologize a little bit for rushing this at the end. The one thing we have been beaten over the head with, please fill out the surveys. We need you to do that, and I think we have to finish now, but we'll stay for the Q&A afterwards. Thanks very much for your time.